Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syami Hadi bin Nasaruddin. My metric number is 2019400618. So for today, I will make a video about straight beam experiment. So without wasting our time, so let's check it out the procedure. First of all, we measure the test specimen to A and B length. So we measure it to 30 cm like this, from point A to point B with 30 cm. Then we mark it with the B point. Alright, then from A to B, we will measure the length with 5 cm with the point A to the point B. So like this, we can see point A to point B with 5 cm. Then we mark it. Five cm. Alright. Then we move to the second point. Like this. Then to the third point. And furthermore, after that, we will put the weight hanger and make sure it add to the point 1, which the distance is 5 cm. Before we put the weight, make sure to reset the weight scale to the 0, and then put the weight to the point 1, and then we will see the weight scale at the A point and B point. After take the read, we will repeat the step by move the hanger to the second point, third point, fourth point, fifth point, until we finish the experiment. So that's all for the today experiment. Thank you. For discussion for the experiment, we have 5 discussion. So for the discussion, I will show my question and my answer in slide in this video. So it will be the same for the conclusion too. So let's check it out the discussion.
Assalamualaikum warahmatullahi wabarakatuh. I am Amirul Hazim bin Roslin. Steel and brass has identical data, which is shearing force, bending moments, Vmax, Mmax for 450 mm. This is because of the same reaction force that they both have. Besides 450 mm, there is a lot of difference, even though the calculation reaction force are the same due to the same load used. The percentage error doesn't have any big difference compared to the experimental reaction value. This might be because of a lot more decimal point is being used instead of lesser decimal point used. Having a lot more decimal points means that your data will be more accurate. Using less decimal points will actually make the data less accurate. 2. How does it work again? Shearing stress will be independent of load positioning, while on the other hand, bending stress will increases as the support distance increases. On the other hand, bending stress will increase as the distance from the support increases. Steel will be stronger than brass because steel data is a lot more higher than brass, meaning that steel can withstand more force before it starts to deform or reach its fracture point. Furthermore, because of steel have a lot more bending moments value, this implies that steel could withstand bending effect if external force apply on it. Number 4. No, because compression will occur when the bending forces happen on the top of the beam, while vice versa at the bottom of the beam. This is possible if the y, which is distance from neutral axis to point of stress, and m, which is bending moment at section, reach its highest. Number 5. Beam is actually a structure feature that can sustain the load mainly by resisting bending. The bending force caused in the material of the beam as a result of external loads, own weight, pan, distance between two indeterminate boards for the structure, and external reaction to this load is called bending moment. There are 6 types of beams. The first one is cantilever, where the beam is only fixed at one side of the end. Second is simply supported. Beam is supported by pin and roller at each end. The third one is overhanging, where the support is not located at the end of the beam. Number 4. Continuous. The beam has 3 or more support supporting them. Number 5. Fixed end. A beam which both ends are fixed onto the support. And lastly, cantilever simply supported. This is a mixture of cantilever and simply supported, where one side is fixed on the support and the other side is supported. In conclusion, all of the objectives have achieved, and we can see that the higher value of shear stress and bending moments, the stronger the material will be, and it will take more force for the material to deform or to reach its fracture point. In this experiment, steel is stronger than brass because of the data which is higher compared to brass. In this experiment, steel's data proven that steel material is a lot more stronger comparing it to brass. Furthermore, errors also could happen in this experiment. For example, taking less decimal points, making the data less accurate. And it is recommended to at least take 3 times the data and calculate the average before writing it down. That's all for me. Thank you.
The discussion session. So the first question is, compare the result of this test of specimen to the calculation of standard values. Comment on any difference and possible source of error. So based on the steel, the calculation of the value, the calculation is less value than the experimental value. Values that being given. Same goes to the reaction force, bending and shear stress, where it also the same value. So based on the press, the calculation is also less value than the experimental, and also same as reaction force, bending and shear stress. Because maybe the error occur during the experiment and the human error occur. So the second is, how does the relative importance of bending and shear stress vary with the loading position of the beam? So by using bending and shearing stress, we can conclude that, and we can calculate and find the shear force and bending moment on the engineering. Because shear stress is to get a net extra bit of moment in the diagram. So bending and shear stress is very important on the loading position of the beam. So the third question is, based on the experiment, would the steel to be stronger than the brass? If so, explain. So based on the result of the experiment, we can see that the steel is very stronger than the brass. It is because when we calculate the bending moment and the shear force, the steel is more than the brass. So we can conclude that steel is more force than the brass. So number 4 is there any difference between the stress measured on the top of the beam and the same location on the bottom of the beam? Explain the both answer. No, it's because the stress on the top of the beam and the bottom is the same. When the beam on the top of the compressive stress, when the beam on the top is a compressive stress, the stress on the horizontal beam is natural 0. So the stress of the bottom of the beam is undergo tensile stress and can be seen through the formula given in the experiment. So the last question is, write and define the classification of the beam. They must be shown in correct diagram. So the first one is simply supported beam, where a beam supported on the ends which are free to rotate and have no moment resistance. The second one is overhanging beam, a simple beam extended beyond its support on one end. So the third one is cantilever beam, a projecting beam fixed only at one end. The fourth one is continuous beam, where a beam extending over more than 2 support. And last one is fixed beam, where a beam supported on both ends and restrained for rotation. So the conclusion is, based on the experiment, the objective is to determine the reaction force, maximum bending stress and maximum shear stress is in the straight beam of the bending test of the test experiment is achieved. So by sketch the diagram above, we can calculate them using the formula given in the theory and sketch the diagram of each specimen. Next, to compare the experimental reaction force with the theoretical values of the loading on the straight beam is achieved. After calculating the reaction force, we can compare the values between the experimental and the calculation, and we can explain why this happened and what is explained in the discussion above of the experiment. So overall, we can conclude that the steel is very stronger than the brass in this experiment.